Figure 4 shows a sketch of part of the curve C1 with the equation y equals 2x cubed plus 10 for positive values of x, and part of the curve C2 with the equation y equals 42x minus 15x squared minus 7, also for positive values of x. We want to verify that the curves intersect at x equals a half. So, we don't need to do any solving here. We can just show that when x is a half, the y coordinates are equal. So, for C1, y is equal to twice 1/2 cubed plus 10. So that's 2 times 1/8 plus 10, which is 1/4 plus 10, which is 10 1/4, or 10.25. Then we'll do the same for C2. Y is going to be 42 times a half. Take away 15 times a half squared, take away 7. 42 times a half is 21. That's going to be 15 times 1/4, and then take away 7. Well, we can do the 21 take away 7 straight away. That's 14. And then take away 15 over 4. So that is 3.75. So take away 3.75. And we can see that that also comes to 10.25. The curves intersect again at the point P. So I'm presuming the half is this one here, and this one is P. Using algebra and showing all stages of working, find the exact x coordinate of P. So, we could put 2x cubed plus 10 equal to 42x, take away 15x squared, take away 7. Bringing everything to the left, we have 2x cubed plus 15x squared minus 42x plus 17 is equal to 0. But we know that x is a half is one solution to this. And that means that 2x minus 1 would be a factor. The other factor must be quadratic. Since we have a 2x just here, it's going to have to start with x squared to get us the 2x cubed here. Since we have a minus 1 just here, we're going to need a minus 17 just here in order to give us the plus 17 at this end. We're not sure what's in the middle, but we can find that middle using a coefficient. So let's use the x squared coefficient, which in the original cubic is 15. What's going to give us an x squared from here? Well, we'll get minus 1x squareds there, and then we'll get 2k x squareds there. So 16 equals 2k, k will be equal to 8. So the quadratic that we need to solve to find this other coordinate is x squared plus 8x take away 17 is equal to 0. Now, I don't think that we are going to be able to find this using factorization. So we can use the formula, or we could complete the square. I'm going to do this one by completing the square. So I've got x plus 4 all squared. Remember that we have a square bracket, we put an x in it, and then half of this coefficient, including the sign. And since x plus 4 all squared is x squared plus 8x plus 16, we want the x squared, we want the 8x, but not the 16. So we need to take off 16, take away 17 equals 0. And that's x plus 4 all squared, take away 33 is equal to 0. So x plus 4 all squared equals 33. And that means that x plus 4 would be equal to plus or minus root 33, given that x is negative 4 plus or minus root 33. Now, one of those answers will be positive and the other negative. And think about where that intersection is and the fact that we were told that x is positive. And so we can say for P, the x-coordinate would be negative 4 plus root 33.